So indeed, I will be giving you a brief update of the status and plans for this new phase of the CAMS policy service, which is now called CAMS 271. It's the first time I'm stepping in to actually present this service to you. And I want to send the hello from Laurence Will, who is sorry for not being able to join here. She's still involved in the project. Her role is now to be the project director, and I will be the project manager. That's why I'm doing this presentation here. But she's following closely the development which we are performing in this contract, which is led by Ineris, but also involves Met Norway, TNO, and NILU. So a lot of this CAMS policy service new contract has to do with a continuation, and you will be able to recognize a few features which were presented to this group in the past. But there's also a few quite exciting perspectives which I want to spend time to show you. Just a reminder, we have a website which really holds everything we produce. It's at policy.atmosphere.copernicus.eu. And on that website, you will be able to access all the products, so the reports we produce, the tools, and various information about all the workshops we prepare and the user interaction. And in user interaction, I also want to emphasize all the material we are producing towards documenting and trying to promote the use of the tools. And a good example is a YouTube video which was actually prepared by Augustin Mortier, who is really guiding the user through step by step what you can do with the tools produced by Copernicus. And I wanted to bring that up front to emphasize that we are really committed to try to accompany the policy users towards taking these tools. Now I will review what we are doing at the moment in this new phase of the contract. The first part of CAMS 71 is about producing reports. So we have two types of annual assessment reports which we produce. One of them is based on interim data, so the analysis which are produced over the fact by CAMS 240 on the basis of unvalidated data, this up-to-date data reported to EA. So that's the interim assessment report. And then we have the validated assessment report, which comes 2 years with a 2 years delay because we are waiting for validated data to come in. We are waiting for CAMS 240 to rerun the models with this validated data. And then the policy service is able to work on the report. So we are working at the moment on the 2021 interim assessment report. And I can already announce the few highlights of that report. As usual, a big part of the report will actually be devoted to the review of key air quality indicators and to put them in perspective in terms of trend assessment. So to say what 2021 looked like compared to earlier years. Of course, for 2021, we have a challenge because earlier years include 2020, which was very unusual for many aspects, but including for air quality, because of the impact of lockdown on air quality in Europe and elsewhere. That's why we have a specific discussion in this report on what we can conclude from the trend between 20 and 21. And in doing that, we are also very glad to rely on the colleagues working on emissions who are able to provide us some insights in the way air pollutant emissions have been kind of recovering. Sorry, the word is very, very, very wrong, but recovering towards normals, towards something more normal than the air pollutant emissions that were occurring in 2020. So that's really important in trying to understand the air quality trends over the past few years, but it will be a big part of the 2021 report. Afterwards, we also have a number of case studies we are working on to document important air pollution episodes which occurred over the last year. Air pollution episode for either ozone, also important episode for desert dust and for wildfire in the summer, and also a case which was quite unusual. It's the Cumbre Vieja, sorry for the accent. It's even worse than English, I think. The volcano in the Canary Islands, which occurred in October 21 and led to a quite unusual dispersion of a plume in altitude over Europe. So the point of documenting these highlights is for policy users to better understand what were the key features of air quality in Europe, but also it's used as a good pedagogical tool to actually introduce the tools that CAMS develops for policy users and show how a step-by-step use of these products can help the policy decision maker to actually better understand the stakes of air pollution. The last bullet point here is to say that over the course of this new contract, in the next few years, we will have an evolution of the regulatory context in Europe with a forthcoming revision of the EU Air Quality Directive. And we also had recently an evolution of the guidelines of WHO. So we also have to reflect in maintaining this report up to date and relevant in this new context. We have to reflect also on these new indicators, these new ways of measuring air pollution and considering whether a situation is satisfactory or not. So this is the points of reflections which we are going to take on board for the forthcoming versions of the assessment reports. Second part of the work has to do with developing tools, and no, this is the pointer, sorry. We are developing several types of tools. One of them is the Air Control Toolbox, which is basically bringing some kind of automated surrogate modeling techniques to air quality. It was really an unprecedented achievement, and I guess most of you have already heard about that because it's now operational since 2018. What is more recent is the fact that earlier this year we published the full methodology in a GMD paper. So what is going to be new in this surrogate modeling tool in this new phase is that we are going to add sector allocation, so really being able to point for several locations what is the key sector contributing to the air pollution episode which is being forecasted. A long time request was to add the shipping sector. So far we only have the sensitivity of traffic, residential heating, industry and agriculture. So we need to add a fifth activity sector, which is shipping. Again, we are only producing results for the everyday forecast. We are going to move another direction by producing annual reports to have act-like type of product, but for annual statistics. We will add also a library of measures and scenarios because it's considered quite an academic exercise so far when you can reduce traffic emission from 0 to 100%. People want to know actually where is located the air quality management plans they are committing to. And including in that direction is to add the NEC scenarios, which the policy service has been producing for many years now. And the last point is the one I want to spend a couple of minutes to present in more detail, is what we call the analogous of chemical regimes. So since we use a surrogate model, we can actually explore a wide range of emission reduction strategies on the fly, really, really fast. It's a matter of seconds rather than hours in a full-frame chemistry transport model. So that's just a couple of slides on how we can be used, these chemical regimes. So I take a case study. It's an ozone episode which occurred in May 2022. It was not a huge ozone episode, but still substantial enough. On the left-hand side, you have the raw CTM simulation. So this is actually coming from one of these air quality models contributing to the regional production. And you can see that there is somewhat of ozone buildup in South Central Europe, but up to Germany and Poland, not in the UK and Netherlands and Northwest France. And what you see on the right-hand side is a typical result of ACT when a user actually go on the web interface and say, what would it look like if I cut all traffic emission? And I really encourage you to go to the website and visit the tool because you will realize that it's actually possible to run this scenario immediately on the website. But the results anyway is just a screenshot of the website that I have here, and it shows that basically when you cut traffic emission, you clearly have a very strong reduction of the ozone daily maximum over the most part of Europe. And there are some areas with a slight increase of ozone. It's a well-known titration effect, but it's actually in areas, typically the UK, where ozone was for that day relatively limited. So this is the type of view which was available in ACT for already a few years. What will be new, and is actually new today already, is the fact that you can access this chemical regime. So what we are showing here is for two locations on the top plot is for London and bottom plot for Madrid, either for ozone daily max or ozone daily average. It's a phase space where the x-axis of each plot is a range of reduction in traffic emissions, and the y-axis is a range of reduction in industrial emissions. And the colors in the back are actually showing the change in ozone concentrations which you expect. Red will be an increase and blue will be a decrease. You can produce that with a chemistry transport model, but basically you need hundreds of simulations of your chemistry transport model. Using an emulator, you can actually produce that for any location in Europe in 1 second. So it's really something that you can do using this type of emulator technique, but with a CTM, it's not really practical to actually do that. And what that tells you, if you start on the bottom left for Madrid, is basically for ozone daily max, if you reduce traffic, at the beginning you don't have much of an effect, basically. It's all white. The concentration of ozone will not change. But if you start reducing traffic emission beyond 50% cut, then you start to see something that is quite interesting in terms of ozone mitigation. When I say quite interesting, it's like 20 micrograms reduction, so very substantial. If you act on industry, on the opposite, here it's actually not so efficient. The reduction is much less, and it's also more linear than for traffic. And you can also go to the extreme case when you act on both, and you see that it's there that you have the most benefit. So here is more like the simple case to start with. You reduce emissions and you reduce ozone, what kind of policymakers expect the world to function. As we know, atmospheric chemistry is a bit more complex than that, and there are a few cases when you have non-linearities or even opposite response. So the opposite response is for the UK. If you reduce traffic emissions, you actually increase ozone. That's typically the titration effect, which even occurs for daily max for that one day in London. What is quite more common is the fact that titration occurs for the ozone daily average. That is something I'm sure everybody was expecting. And the typical complex plot which needs to be explained a lot to decision makers is what you have on the bottom right. For Madrid, for the daily mean ozone in Madrid, if you only act on traffic emission, you basically will go towards an increase, except if you really go to the extreme case when you reach 100% reduction of traffic emissions. But if you also act on industrial emission, you can be more beneficial even at a low range of traffic emission reductions. So this is typically explaining for one given situation the way ozone chemistry works on a very pedagogical point of view. But it can also be used for the decision makers to design the mitigation strategies they want to implement on the fact. I need to speed up. So I will move to the other tools which we are producing. We have a source allocation service, which is actually produced by Met Norway, looking more at the geographical contributing to air pollutant. It also includes a lot of information about the chemical composition of PM, a lot of information which is not available from the regular production, the official production. So really encourage you to go there. And it's available both for the daily forecast and the yearly statistics. So that's also something which is very welcome by the users. What will be new in the next phase of the contract, maybe it will not be seen by so much the users, but it's a huge change for us. It's a total change in the methodology, where IMEP is actually going to move towards what they call this local fraction, which is also used in the UMEP downscaling model, when they have a total different change in representing the source allocation in the model, which is also something that can be used for downscaling and very high resolution modeling in the IMEP model. So that will be allow us to add many more cities, which compared to what is already available, but also look at non-linearities and the effect of boundary condition. Another type of activity is the analysis we're doing for air pollution episode. So, like I said, we have a number of tools, but the user want to know how to use these tools. That's why every time there are substantial air pollution episodes at the scale of Europe, we produce a report illustrating how the tools can be used. Again, it was done recently for March 22, a dust episode. The report is on the website. But we are also closely monitoring the air quality forecast at the moment as we speak, because IMEP is actually going to trigger a campaign devoted to ozone forecast. And there is a really strong interest in ozone mitigation at the policy level at the moment, mainly because the long-term trends of ozone are considered to be not so satisfying compared to other type of pollutants. So IMEP is starting this campaign relying on passive sampling, but they need some guidance of the forecast. And in that context, CAM71 is also implementing its tool and expertise to support this effort. I think it's my almost final slide. We are also for policy support designing targeted studies, so multimodal analysis of prospective scenario analysis. So in this phase, we are working on prospective scenario, but in the earlier phase, we are committed to work on the multimodal COVID lockdown type of analysis. So here we are looking at eclipse scenarios produced by IASA, but also at methane scenario, which is very high in the policy agenda at the moment in Europe. And we implement 3 regional models, but also work in close collaboration with ECMWF, because the IFS model is actually used in the same analysis framework. I'm just showing that for illustration. The response of the 3 regional models and the global models are actually very similar in terms of looking at ozone annual mean change. So that's clearly something that was interesting, which we will be looking at further in the future. But to finish, I want to highlight that we have also other topics in collaboration with policy users. We are preparing a policy user workshop, which is scheduled for the fall this year. We are also committed to work with the CAMS National Collaboration Program, which is also relying on some of the tools which we develop in the policy service. So this will be an interesting way forward for the service developers. And we also have a strong axis of collaboration with FAIR-MODE. Like I said, the Ambient Air Quality Directive will evolve in the future, and FAIR-MODE is likely going to play an important role, but CAMS can also play an important role. We can mention the issue of exceedances reporting. The countries have to report exceedances, and in the case of exceedance, they can also point cases where natural sources are important, and there our product on dust modeling can be specifically important. FAIR-MODE is working a lot also on sector and source allocation. We are doing also specific development in that direction, so keen to discuss also the methodological developments. And we also have a number of maps of air pollutants beyond the classic air pollutants, which are from the CAMS models, which can be used in that context. With that, I'm finished. Thank you.
Questions? Yes, one.
Thank you. This was quite interesting with respect. I'm dwelling on the slide with London and the Madrid issue. It's quite interesting to see this fairly traditional analysis enlarged by sectors and not typically by NOx and VOCs. So, which also makes similar type of diagrams. So, as you claimed that this is too costly to make this with 3D chemistry transport models, but did you take into account some dilution effect and of the metropolitan area development where the ozone burden is larger than inside cities typically? So this would be the more practical issue. Inside cities you can quickly mix any combination locally by street canyon to get this or another result.
I said it's not possible to do it with a CTM. What's not possible is to fill the whole space with a CTM. Of course, with a CTM, you can actually sample this phase space. It's actually the very way it's designed. There is a CTM. Every day, we actually run 15 simulations of Chimère, and that's how the statistical model is driven. So that's the way it works. Every day in the operational production, it's just not one Chimère simulation, but 15. And in doing 15, we have to degrade a bit the resolution. And typically, we miss really local effects. It would be even worse if we go to the street level. Of course, the chemical regimes would change. So far, we are producing this at the scale of the map, which is there, typically a 20-kilometer order of resolution. But we also have plans to actually do the same at a much higher resolution, or much higher, like 3-4 kilometer resolution, typically over France. And typically, it's something that could be promoted in the framework of a national cooperation program when you have such a tool developed for Europe, which gives different results if you actually operate over one country where the titration regime is working in a different way. Then there is the question of running it at the scale of one city. You're going, again, one step beyond. I'm not aware of anybody planning to do some surrogate model at the scale of city dispersion. But what I can say, it's doing the same at the scale of a country like France is already in the pipe to address the problem.
Thank you. Thanks for the presentation, Augustin. I have one question. So in the ACT toolbox, I see that you do not include the use of solvent sector, despite that it contributes to more than half of total VOC emissions. Is there a specific reason for that? It's because the chemical transport models are not sensitive to changes to this sector, or is because if you look at official emission projections, all of them, they basically say that the emissions from this sector will keep constant or even increase a bit, or what? Is there a specific reason for that?
No, there's no reason. It's just at first we designed it with these four sectors. We had clear requests to add shipping. We didn't have so clear request to add solvent. Maybe we should actually bring solvent with industry. I don't know. I mean, yeah, we should add it, and I must admit that I haven't tried to do it yet, so I'm not aware of any difficulty, but maybe I will discover something when we try to work on it. I don't know.
Thank you. Thank you, Augustin.